Welcome to PrimeStar Automotive. Whether you are an automotive beginner, student, an apprentice, technician, or enthusiast, you are in the right place. This is Lesson 008, Identifying Vehicle Steering Components. In this lesson, we will identify the major steering components, locate them on the vehicle, and briefly explain their function. Before we begin, I want you to remember that this is Lesson 008. If you need some refresher knowledge, you can go to Lesson 001 to 007. Now, going back to this lesson, I will begin with a question. What is a steering system? It is the group of components that carries the driver's steering input to the road wheels. We will identify now those components, locate them, and briefly explain each of these functions. For the purpose of this lesson, let us remove the vehicle body so we can see the internal components, especially the steering system. Now this is the vehicle looks without its body. For the purpose of understanding this lesson visually, we will remove the engine and the gearbox assembly. This gives us a clear view of the steering system and its major components. The steering system is now exposed. We can begin identifying its major components and seeing where it is located in the vehicle. So let's begin with the identification. Now look at the steering wheel. The steering wheel is the driver's primary steering control, located inside the passenger compartment, directly in front of the driver. The driver turns it to begin steering input. The steering wheel starts the movement, the column carries it. We will go into great details on the steering wheel on our future lesson. Next is the steering column. The steering column supports the steering wheel and contains the upper steering shaft, located from the steering wheel below the instrument panel, towards the bulkhead or firewall. It supports the steering controls and provides a protected path for steering rotation. The column guides the input toward the intermediate shaft. Next is the intermediate steering shaft and its universal joints. It is located between the steering column and the steering gear, commonly passing through the firewall. The shaft carries steering rotation, while the universal joints allow it to operate through different angles. Introducing the next component is the steering gear designs. In this lesson, we will identify two common steering gear designs. The first design is the rack-and-pinion steering, which is commonly used in modern vehicles. And the second design is the circulating-ball steering gear, commonly called a steering gearbox assembly. A steering box assembly connects the steering shaft to a separate steering linkage. It is commonly found on some heavy-duty four-wheel drives, utility vehicles, and trucks. To give you an example, let's look at the underneath of this Jeep Wrangler and find the steering box assembly. Notice the gearbox is highlighted in red. We will explore the steering operations in great details in our future lessons. Next is the steering linkage. Steering linkage are the rods, arms, and joint between the steering gear and the steering knuckles. They are located across the front axle or subframe, and transfer steering movement towards both front wheels. Next is the tie rods and tie rod ends. Tie rods are adjustable steering links with spherical tie rod ends. They are located between the steering rack or the center link and the steering arms on the knuckles. Their function is to push or pull the knuckles so the road wheels can turn effectively and efficiently as commanded by the driver. Left front right tie rod and tie rod ends. In this image here, the steering linkage is highlighted so you can identify the tie rods and see where they connect between the steering gear and the steering knuckles. Note that in automotive industry, it is a standard that we determine the left hand and right hand when you are sitting on the driver's seat facing forward, and that is your left and right parts of the vehicle. Look closely at each end of the linkage. The inner and outer tie rods carry steering movement toward the steering knuckles. Here are the tie rods in focus. They form the final physical connection between the steering gear or the steering rack and the steering knuckles. When the tie rod moves, they push or pull the knuckles. Next is the Pitman arm and drag link. The Pitman arm is fixed to the steering gearbox sector shaft. The drag link or center link connects it to the remaining linkage. It is located beneath the steering box, across or along the front axle area. The Pitman arm changes gearbox output into linkage whip. The drag link carries the movement towards the wheels. These parts are associated with recirculating-ball steering systems, or the famous known as steering gearbox system, not as basic rack-and-pinion layout. Now watch as we are zooming the Pitman arm and drag link to have a better view of what it looks like when it is connected to the drag link. Now what you see here is the Pitman arm in focus by its own. It is fitted to the output shaft of a steering box and transfer steering box movement to the drag link. Next is the steering knuckle, sometimes called a spindle in some designs. The steering knuckles carries the wheel hub and steering arm, located at its front wheel, between the suspension links and the wheel hub assembly. It pivots so the wheel changes direction while remaining connected to the suspension. It is connected to the tie rod's movement, which turns the knuckle left to right and center. Here is the steering knuckle in close-up view. The steering knuckle carries the wheel hub and steering arm. It is located at each front wheel and pivots when the tie rod pushes or pulls it. This is a steering knuckle in focus. Depending on vehicle design, it may support a driven hub or include a projecting spindle or stub axle. We will explore in great details the designs of steering knuckle in our future lessons. Here are more additional of steering knuckles and spindle designs depending on brand and manufacturers. Note that the main identifying features of steering knuckle and spindle. Non-driven spindle type knuckle, they are used for vehicles like rear-wheel drives or two-wheel drive cars, utilities vehicles, and trucks. Has a solid projecting spindle on or stub axle. The wheel hub and bearings rotates around the spindle. There is no front drive shaft. Driven to hub knuckle are also used on some front-wheel drive or and all-wheel drive and many independent front four-wheel drive vehicles. Has a large center opening and the CV shaft or constant velocity drive shaft passes through the wheel bearing and spline hub. We will introduce this to you in greater details in our future lessons. At this stage, we'll just have to understand what it looks like, identify the parts, and simple description of it. Let's not complicate these beginning lessons. Ball joints at the steering knuckles. A ball joint is a spherical bearing fitted between the steering knuckles and suspension. It allows the knuckles to pivot for steering while the suspension moves up and down. Ball joints are commonly fitted where the control arms connect to the steering knuckle. They support steering movement, but they are also major suspension components. There are several common ball joints designs. We will identify them briefly now and examine their construction in future lessons. This example here shows a press-in ball joint and a bolt-on ball joint. A tie rod end also contains a ball and socket joint. It allows the steering linkage to pivot while remaining connected to the steering knuckle. Now introducing. Next is the power steering assistance, also called power assisted steering or PAS. It reduces the effort required from the driver. Power steering assist or power assistance reduces the effort required to turn the steering wheel. And there are two common types covered here in this lesson. They are the hydraulic power steering system and the electric power steering system. The hydraulic power steering, which uses pressurized fluid, and the electric power steering, which uses electric motor. We will explore their great details and operation in our future lessons. Next is the rack and pinion steering system, or a conventional steering rack assembly. It is a mechanical linkage mechanism that converts the rotational movement of the steering wheel into the linear movement needed to turn the wheels of the vehicle. A rack and pinion assembly includes the rack housing, pinion housing, bellows boots, and tie rods. It is mounted low across the front of the vehicle. The pinion rotates against the tooth rack bar or rack shaft, moving the rack left or right and pushing or pulling the tie rods. Here is the rack and pinion steering assembly in focus. Notice its position across the front of the vehicle between the two road wheels. This closer view identifies the pinion input section of the rack and pinion steering assembly. Pinion gear is housed here, where the steering shaft connects to the steering rack assembly. This cutout shows the internal pinion gear and tooth rack shaft or bar. We are only identifying the components here. Their detailed operation will be covered in our future lessons. Hydraulic power steering system includes a pump, reservoir, fluid, pressure and return hose, and hydraulic steering gear. Hydraulic power steering uses pressurized fluid to assist the driver's steering effort. We will examine the hydraulic operation in details in our future lessons. The engine drives the hydraulic pump through a belt. The pump draws fluid from the reservoir and supplies pressurized fluid to the steering gear. This example uses rack-assist electric power steering, with the assist motor mounted directly on the steering rack. Electric power steering uses an electric motor and electric controls instead of a hydraulic pump and fluid circuit. The motor may be mounted on the steering column, pinion, or in a rack. The steering torque sensor detects the driver's effort, the control unit calculates the required assistance, and the electric motor supplies that assistance. Next is a steering damper. It resembles a small shock absorber. The steering damper is commonly located between the steering linkage and the axle, while in some other four-wheel drive and heavy-duty vehicles, it is located on chassis or frame. The steering damper's job is to reduce steering kickback, vibration, and road shock. Our example here shows one typical steering damper location on a four-wheel drive vehicle. The exact mounting position will vary between vehicle manufacturers and design. Next is the steering angle sensor. It monitors the position and direction of the steering wheel. It is commonly fitted on the steering column beneath the steering wheel, often near the clock spring. It sends steering information to systems such as stability control and electric power steering. The sensor only measures steering movement. It does not mechanically turn the wheels. This cutaway image shows the steering angle sensor fitted around the steering shaft behind the steering wheel. Now, let us review the complete mechanical steering path in a typical rack-and-pinion system. The steering path begins at the steering wheel, where the driver applies the steering input. Turning the steering wheel begins rotational movement in the steering system. The next components are the steering column and shaft. The steering shaft rotates with the steering wheel and carries that movement toward the steering gear. Universal joints allow the shaft to transmit rotation through the angles between the column and the steering gear. At the steering gear, the shaft connects to the pinion gear. When the steering shaft rotates, the pinion gear rotates with it. The pinion gear meshes with the tooth section of the steering rack. As the pinion rotates, the rack shaft moves horizontally left or right. Next is the steering rack. This converts the steering wheel's rotational movement into the rack shaft's linear movement. Tie rods are connected to both ends of the steering rack. Each side includes an inner tie rod and an outer tie rod end. As the rack moves, it pushes one tie rod outward while pulling the opposite tie rod inward. The tie rods connect the steering rack to the steering knuckles at the road wheels. Each outer tie rod end connects to the steering arm on a steering knuckle through a ball and socket joint. Now look closely at the steering knuckle and road wheels. The knuckle pivots about the steering axis when the tie rod pushes or pulls it. We are going to discuss in great details about steering axis in our future lessons. This movement turns the road wheel left or right. The outer tie rod end connects to the steering arm on the knuckle through a ball and socket joint. When the tie rod pushes or pulls, the knuckle pivots around the steering axis and turns the road wheels. And that completes the steering path, which starts from the steering wheel, column shaft, steering gear, tie rods, steering knuckles, and road wheels. And now we are going to apply what we have learned so far. Take your time and take a thorough review. This is the time you read and follow the suggested knowledge check in this section, and do it in your own space and time. Now I want you to check your answers in here. Thank you for joining Lesson 008. You can now identify the major steering system components, locate them in the vehicle, and briefly explain their functions. Continue learning, continue improving, and we look forward to seeing you in the next lesson. You can subscribe for more future lessons in the Automotive Fundamental Series.